Okay, now we can start. Right. Welcome back to class, everyone. Hopefully you had a really good week. What are we looking at today? Today, we're not going to look at like any new topics. Today, we're just going to look at, as you can see here, math contest writing. So what's this all about? So this is not like a new math topic or anything. Or basically, I don't know, it's basically like applying like all of the stuff that we learned before and like maybe try out on some problems. So I guess you could call today's lesson, it's not really like a lesson. Say it's like a bit more relaxed than before. So you don't have to learn anything new. Actually, there's some stuff to learn, but let's check it out. So, why would you want to write a math contest? That's the reason. So, what are some reasons that you want to write a math contest? Hopefully, you guys signed up for this course because you want to improve your math contest writing skills. But why would you want to write one other than that? First of all, it enriches your problem solving abilities. So, as you solve problems, you'll be able to, as you practice more and more by solving problems, you can easily be able to, solve similar problems in the future. That's why math contests help with that. Math contests also introduce you to complex and fascinating topics that they don't teach you at all at school, elementary school, or even high school. Examples are like, I don't know, combinatorics, maybe some probability stuff, some geometry that's also not taught at school. They basically, they basically use like the topics that you learn, but then they just go like levels beyond that. So yeah, math contests, pretty cool. And then math contests can also prepare you well for advanced level math. So say you're doing like a I don't know, like a grade 8 math contest right now, it'll probably use some like high school math that you haven't learned yet, but you'll use later when you actually enter high school stuff. And they'll might also prepare you for like university math and etc. So that's a good cool thing about it. And if you say if you get a prize at math contest or like you do very well, really well, you can show off your results to others. Math contest wins are a great way to show to others, show them how like strong your like your problem solving skills are. And final reason is because because you're in this class. Hopefully you came to this class just to learn how to up your math contest writing skills. Yeah, that's what this course is basically all about. It's called Olympic Math just because it's about contest math, right? All right. So those are some like I don't know, some good reasons why you'd want to like write math contests. I don't know if there are any like any contests coming up soon for you guys, but you guys can check it out. So like I know like CMC, so like University of Waterloo's math contests. Yeah, their math contest organization. I think they're gonna have one coming up soon. It's called the Gauss contest, and it usually happens like May or something. So you can look that up. And there are a bunch of other ones too from like other organizations. I heard one called like the Kangaroo contest. I think that's coming. I think that already passed, but I'm not sure. And there's also others like Caribou and so on. But yeah. Okay, so those are some reasons why you want to try math contests, but like let's look at some like a couple of tips on like how you go in solving like contest problems. And this is like really general. It's not like specific to like any kind of problem, but like yeah. So these are some general tips on how you solve a contest problem. It's not like it's not teaching you any like strategies on like how to actually solve it because like each question is like it requires like specific formulas and stuff. Like these are some general tips. So like the first tip would be to like read over your question carefully. So make sure you don't skim over any details, any large ones or especially small ones. You don't want to skip over those, or that could really change the answer depending on what kind of question it is. Right. So read the question carefully. Next, the other tip: if the problem is like geometric, so say it's like it's involving like shapes or something, or just like a general diagram, you always want to draw it out. So you always want to draw out like a diagram of it, the shapes, so you can visualize the problem. If usually they'd provide like a diagram for you, so you don't have to draw it out, but it'll still be helpful because usually a lot of geometric problems they require you to draw these helping lines. So helping lines are basically like lines that are already not part of the diagram, but that you draw in yourself, and that can really help you, get yourself closer to the solution. So yeah, lots of geometric problems. they require you to draw some helping lines just to get you closer, get you to an actual solution. So yeah, so remember this tip. This is pretty important. And then we also have some lots of algebraic problems that appear on math contests. So if they're algebraic, it's pretty straightforward. You try to like find out like what variables you need to be solved that need to be solved. Oh, got some new people joining. Okay, it's Thomas. All right. So if the problem is like algebraic, you want to find out like what kinds of variables that need to be solved, and then express some equations like that include those variables, and then you try to solve those variables. So that's pretty straightforward for algebraic problems, but they appear a lot, so just remember that. And then some other general tips. So these are more for like more complex problems. Like as you get to the end of a contest, usually they're like increasing difficulty. So these are like the final problems or something. So a great thing to do is to find efficient solutions and use like really basic techniques, like the basic formulas like Pythagorean theorem, or like, I don't know, it's like addition, subtraction, or arithmetic. Just use those basic techniques. You don't want to like go too complex into a solution. Okay, one person joined. I think we're almost full class. But yeah, oops, did I mean to skip forward? So yeah, you want to find some efficient solutions and try not to like brute force any problems. So like don't try to like guess and check or anything. That's basically what, like brute force is. Unless it's like really necessary. Sometimes you may need to brute force it. But yeah, usually that won't occur. And then if the problem is like extremely complex, so say it has like, I don't know, lots of cases, like you're trying to find like a really large number or something, try to split the problem into smaller cases. We'll look at an example of that later, so like what the case would look like. So splitting it into smaller cases or like simpler problems, and also try to find patterns in between those. That'll really help you like condense a bigger problem into like a couple chunks of smaller problems, and then you basically like add up all the values or something. That's usually what happens. You add up all the values and you get your final solution for the big problem. Right? Any questions about this? Any questions about this slide or the previous slide? Oops. Hopefully there are no problems. So yeah, that's all the things you're going to learn for today. The rest of the presentation is just solving problems. That's what we're going to do today. So what I did was scrape some of the problems from the 2017 Gauss Math Contest. So this is from the CMC, so University of Waterloo's. And these are the rules if you read them on the left. So if you've never seen this contest before, these are the rules of the contest. It's basically like you have 1 hour to do it, and it's multiple choice. So there's like option A, B, C, D. So it's 5 options for each question. And then here's the scoring part of it. So each of the questions are split into 3 parts. You have part A, part B, and part C. So like part A is like questions 1 to 10, part B is questions 11 to 20, and then part C is 21 to 25. So there's 25 questions in total. And they're in increasing difficulty. They didn't mention it here, but they get harder and harder as you go along. And that's basically true for all contests. And then you can see how it's scored, right? So you have 5 points part A, 6 points part B, 8 points in part C. No penalty if you get anything incorrect. And you can get 2 points if you don't answer a question, but you can only get a maximum of 10 unanswered questions. And yeah, that's about it for the rules. So let's jump into some problems. We're not doing like all the contest problems because like we don't have, of course, we don't have time to do that today. Even though it says like you should be completing this in 1 hour, but we won't have time for that. So I basically choose like, I believe like there's around 10 problems on the slideshow. So let's take a look. And they're going to be increasing difficulty. So first few are going to be easy, like this one. It's going to be pretty straightforward. And then we're going to go into some difficult ones. So let's look at this one. It's problem number 4 on the contest. Here it says there are 160 students in grade 8 at Murray Public School. If exactly 10% of these students are on the school's chess team, how many grade students are on the team? Right. That should be a very, very, very straightforward problem. So if you have an answer, just type in chat or unmute yourself. You can say the number or the letter. Anything works. letter as in these ones. So A, B, C, D, E. So what's the answer for this problem? B. Perfect. Yeah. So you're just taking 10% of 160, and hopefully you know how to multiply numbers by percents. Or if you don't, you can just convert this into a fraction, which would be like 1/10, and then multiply that by this number. You get 16. So very straightforward. Okay, let's look at problem number 8. So this is algebraic, if you can tell. So you see when a number is tripled and then decreased by 6, the result is 15. And what's the number? I mean, you could probably do it without algebra, but D. Elaine says 7. I think 7 is, let's see. Yeah, I think 7's correct. Whoops, that means I should go back. Yeah, 7 seems to be the right answer. So let's just do this really quickly on the whiteboard. So basically, like, this is an algebraic problem, and you want to, like, solve it using an equation. So, like, say you represent the number with, like, x or something. So you use x to represent the number. So if you triple it and then decrease it by 6, so triple it, so that means you multiply it by 3 to get 3x. Right, that 3 is really ugly. So 3x, and then plus, decrease by 6. So that's minus 6. And that gives you 15. Basically, you just solve for x in this equation. It's a very straightforward one. So 3x would give you 21. You just add 6 to both sides, and then you just divide by 3 to get x equals 7. There you go. Let's go back to slideshow. So x is equals 7. So your answer for this problem would be D right here. Okay, that was very straightforward. So yeah, the first two, those were part 8 problems. This is also part 8 problem. This is the last problem on part 8, problem number 10. So you see it's a geometric problem, and also it provided a diagram for you, so you don't need to really draw it out. Yeah. So line segments PQ and RS intersect at T, this point T as shown. If TS is congruent or is equal to TQ and angle PTR is 88 degrees, what's the value of X? So this angle right here. B. Elaine says B. Yeah, I believe that's correct. Let me wait for the others to actually, think about why it's B, Okay, let's solve this on a whiteboard. Let me see if I can upload a picture, upload image. Yeah, we can do that. Let me try to remember which problem it was. I think it was this one. Perfect. So expand it out. All right, perfect. We can use this image. Nice. Right, so let's analyze this diagram. Right, so we have this angle right here. PTR is 88 degrees. TS, congruent to TQ. And you see, so that means that TSQ would be an isosceles triangle if you have two sides that are equal to each other. All right, so how do we solve this? So we're given only like one numerical value, which is 88 degrees. What you want to do is to move it inside the triangle, like where, like basically where the angle X is. So we want to move it in there. How do we do that? Well, if you know opposite angles, PTR, so this angle right here, 88 degrees, would actually be equal to STQ because they're opposite to each other, as you can see, basically opposite. So that means that this angle would be 88 degrees. All right? So this angle is 88 degrees. And how do we find angle X, though, even though we're not given what this angle is right here? Well, since we know that this triangle is isosceles, that means since there's two sides are equal, then two angles have to be equal as well. And so this angle right here, TQS, that will actually be equal to angle X. These two would be equal to each other. And then from there, you can just basically use an equation to solve for X. So you get X plus X, we'll just write it as 2X, plus A8, would give you 180. So that's the sum of all the angles inside triangle, the interior angles. What's that? And then you're just solving for x, right? 2x is equal to 180 minus 88 should give you 92. So that means you're left with x is equal to 46. So you divide both sides by 2. And that's how you get your angle x. Right? And so on the contest, you would circle answer B right here. That's what you would circle. Okay. So those were the part A problems. So those are very, very straightforward. Let's move on to some more difficult ones. So now we're moving to part B. Let's look at this one. Problem 13. The sum of the first 100 positive integers, so 1 plus 2 plus 3 all the way to 100, equals 5050. What's the sum of the first 100 positive multiples of 10? So 10 plus 20 plus 30 all the way to 1000. What is that equal to? Aiden says C. C is correct. We'll see why. Okay, let me give the others some, let me give the others some time to think about it. Think about why it's C. So this one, 50,500. Okay, let's take it up. Hopefully everyone understands why it's 50,500. But I'll explain it. How do we? There we go. Pan. Let's move to a different spot on the whiteboard. Let's try this. Okay. And I think I can just text this out. Type it out. So we're given that the sum of like all the integers from 1 to 100, that's equal to 5050, right? And we want to find out the sum of the first 100 multiples of 10. So 10 plus 20 plus 30 plus all the way to 1000. That's what we want to find out, right? Okay. So obviously you could just add all these numbers up, but like that would take a really long time. You don't want to do that. Want to find shortcuts. As we said before, you want to find efficient solutions to these kinds of problems. So if we look at this first sum and we compare it to the sum below here, so this sum right here, you notice that each of the numbers, so if you like line them up, each of the numbers, so 1 and 10, 2 and 20, 3 and 30. So each of these numbers below are 10 times the numbers above here, right? So they're multiples of 10, so that means that they're 10 times larger than these values over here. And so what you can do, you can take the distributive property of each of these numbers, use distributive property, so like factor out 10 from each of these numbers. And what you're left with is this. So we get this in the brackets now. So when you factor out 10 in the brackets, you're left with 1 plus 2 plus 3 plus all the way to 100, which is the initial sum that we have, so which is 5050. And then basically, you can just substitute this number directly into this for this bracket. So you can directly just substitute that. So let's write down the next line. Hopefully everyone understands why I substitute this with 5050. It's because of this first line right here. It's like, you can think of this as like equation or something. So basically substituting this number into this large sum, and that'll give us an answer of 50,500. So 10 times 5050. This would be your final answer. All right, hopefully everyone understands that. And so on the contest, you would circle answer C. There you go. All right, any questions about like all the problems that we have so far? Anyone have any questions? Yeah, Aiden, it's 5. Yeah, it's basically that, but like explain like why it's that though. So yeah, I basically explain why it's 5,050. Sorry, 550 times 10. Yeah, 5,050 times 10. Oops. All right. Hopefully there are no questions. Let's move on to more difficult problem. So problem number 18. Brody and Ryan are driving directly towards each other. Brody is driving at a constant speed of 50 kilometers per hour, and Ryan is driving at a constant speed of 40 kilometers per hour. If they were initially 120 kilometers apart, how long will it take before they meet? Right. So it's a step up from the previous problems. So I'll give you guys like a minute to think about it. See how you solve it. Jerry says it's E. I think it's E as well, but let's wait for the others to finish. Okay. I think I'm gonna take it up right now. Let's take it up. So it asks you find the time. You want to find time. How long it take before they meet. And so a way to do this, we'd actually use an equation to solve for it. But first, let's draw a diagram. So it's just to visualize the problem. Even though it's like not geometric, we can still use a diagram to like visualize it. So we have Brody driving constant speed of, let's use this arrow right here. So Brody's driving constant speed of 50 kilometers per hour. And then from the other direction, we have, forgot the other name, we have Ryan driving at 40 kilometers per hour. So let me just put those in. Oh, where's my, oh, here we go, pen. So this is 50 kilometers per hour. And then we have on the other end, a person driving at 40 kilometers per hour. Oh yeah, and then this total distance right here is 120 kilometers. So that's what we're, this is the diagram that we're drawing at. We're basically representing this entire line as the total distance. So Brody was right here, and we had Ryan on this other side right here. So they're 120 kilometers apart initially, and then basically they're moving towards just one point, and it'll be around here. Brody will actually travel more than Ryan just because he's traveling at a faster speed. So just a bit over the half point of 120 kilometers per hour. Kilometers, sorry. So say they meet at this point right here. All right. Okay. Now what do we do from here? What are we gonna do? So I mentioned that like Brody would travel like a bit of a further distance than Ryan, just because he's faster speed. But what is that distance? It'll be, I think we want to figure out what that distance is. So let's call that distance D. Sorry, let's call his distance. So Brian's distance, sorry, Brody's distance. We'll call it D. Let's just be right there and just put Brody's distance. me just type that out. So if D is Brody's distance, like when he meets Ryan, so let me draw it out. So this distance right here, that's D. Now what about this distance right here? So distance that Ryan travels. So this distance right here. So notice that D, so Brody's distance plus Ryan's distance would actually equal 120 kilometers. So that means that basically you would subtract 120 by D to get Ryan's distance. So this would be 120 minus D. So if D is Brody's distance, that means that 120 minus D is equal to Ryan's distance. So now that we have these, but we're not given the distances, we're given their speeds. So we have 50 kilometers per hour over here. We have 40 kilometers per hour over here. So if you guys know the distance speed time equation, it's basically, so we have distance is equal to speed times time. So that's the equation. Hopefully you understand why that is. So say I use 40 kilometers per hour as the 40 kilometers per hour as the speed. Say I just had 1 hour travel time, so 1 hour would be your time. I just multiply both these together to get distance, which is 40 kilometers. So 40 kilometers per hour times 1 hour. And you can see if you write the units for these variables, so this is kilometers per hour, and time is in hours, you see that these hours would cancel out, and you're left with kilometers to get distance right there. So that's how that equation works. Right. So yeah, we can express, so instead of expressing these as D now, we can express them in terms of S and T, so speed and time. And we're actually solving for time, right? We're solving for T, what that is. And so if Brody travels a distance of D, and Ryan travels a distance of 120 minus D, that means they took the same time to travel that distance. So T would be the same for both of them. Hopefully you guys understand why. But, right, so D, we're looking for Brody's distance. This would be 50 times T. So Brody's speed is 50 kilometers per hour. Now Ryan's distance, so 120 minus D, that's equal to 40 times T. So this is Ryan's distance. So, okay, first equation, this is Brody's distance. Right, we use this equation speed times time. So Brody's speed was 50, and we're multiplying that by an unknown time, so T. So that's Brody's distance. Now for Ryan's distance, so remember we calculate as 120 minus T initially, and this is equal to his speed times the same amount of time, because as they get to the one point, they use the same amount of time to travel there. So this is 40 T. And now we're just trying to solve for T, right? So that's what we're trying to do. And the simplest way we can do that is substitute. So we have the value of D right here. We just substitute directly into this D right here. So let's do that. So we have 120. Let's type it out. Actually, 120 minus 50T is equal to 40T. You're just solving for T. So let's move, it'll be easier to move T to the right side instead of the left side. So we have 120 is equal to 90T. T, if you divide both sides by 90, you get T is equal to 1.5 hours. Wait, no, not 1.5, sorry. So 120 over 90, that would give you 4 thirds. So it would be just like 1.33 if you rounded it, 1.33 hours. So 1 and a third hours. So what is that? in minutes. So 1/3 of an hour would just be 20 minutes. So it would just be equal to 1 hour and 20 minutes. And that should be your final answer for a problem. Oh, someone joining. Oh, Devin just joined. All right, now we have a folk class. Yeah, Devin, what we're doing today, we're just basically solving math contest problems. So not learning anything new today. We're just, practicing our skills with actual problems. Yeah. So for this problem, you would circle question E. Answer E, 1 hour, 20 minutes. That's how you get the answer to this question, right? Any questions about this? Oh yeah, the internet problems. So yeah, no worries, Devin. Hopefully you get them fixed by next time. Okay, let's move on to problem 19. This one. So in a group of 7 friends, the mean or average age of 3 of the friends is 12 years and 3 months. And the mean age of the remaining 4 friends is 13 years and 5 months. And in months, what's the mean age of all 7 friends? So hopefully you guys know what the formula for like an average is. You're basically like adding up all the values and just dividing it by the frequency or like the number of values there are. Right? That's what the average is. Right? I think the values for this seem to be, I don't know, pretty big. So probably be good to like use a calculator for this. Does anyone have an answer so far? Or not yet? Oh, sorry, I forgot to share the tab. Okay, my bad. Here, this is the problem. Sorry, guys. Here's the problem. You can look at it again. Forgot to share the tab. My bad. Changlong got E. I think I think that's the right answer. Let's take it up. All right, hopefully you guys had time to digest that problem. Let's try to solve it. Okay, let's move to a new location on the whiteboard. Let's use this space. So the mean of 3 friends. Sorry, the average age of 3 of the friends. So there's 7 friends in total. 3 of the friends have an average age of 12 years and 3 months. And let's rewrite that in months, just because the final answer wants it in months. So 12 years, 3 months. Convert that to a number of months. It's the years multiplying number of years by 12. So I'll give you 144. And then you add 3 months to that. That will give you 147 months. So that's for 3 friends. It's their average age. Now for the remaining 4 friends, their average age is 13 years and 5 months. So 13 years and 5 months. If you convert that to months, so you multiply 13 by 12, that would get you 156, if I'm not wrong. Yeah, 156. All right. and then you add 5 to that, so you get 161 months. Right, so these are the ages in months for each of those friends. But so we want the average age of all of those friends, however. So we're given that the age of Street of Friends is 147 months. So Street of Friends have 147 months. So that means we want to multiply that. Want to get our final average. Right? It's like how average is calculated. You basically add up all the ages of the friends and then divide that by the number of friends, right? So if we want to find like the sum of all their ages, we want to like multiply the average by the frequency, so like number of friends there are. So I multiplied 3 by 147. And what we want to add to that is, so we have 4 of the friends that have an average of 161 months. So that means if we want the sum of sum of the ages of all 4 of those friends, we just multiply 4 by 161. So it doesn't matter like what their exact. We don't really care about what their exact ages were. We just care about like the sum of it. The sum of it, which we just multiply the average by the number of friends there, and that will still give us this same sum if we were to like add up all their ages individually. You guys understand that? So yeah, if you calculate this, well, let's not calculate it. So this would be the sum of all of the ages of all 7 friends, right? Hope you guys understand that. And then if we want the average of all the friends, we just divide that by the number of friends there are. So, well, yeah, let's calculate this actually. And then we just divide that by 7. And yeah, it'd be easier to use a calculator for this. Just because those are some big numbers. So if I do that, you get 1,085. What you get for that's in months. So that's the sum of all of the ages of the friends. And then to get your final answer, you divide that by 7. There's 7 friends in total out of this group. So if you divide that by 7, you'll get your average age for everyone. And this turns out to be 155 months. Final answer, 155. So if you went back to the slideshow, you would circle answer E. Right? Any questions about this? Any questions? Okay. So that was problem 19. So you notice that, so from problem 13 to problem 19, these are all part B problems. And now the remaining ones are going to be part C problems. So you can see the next one's problem 22. This is part C now. And this is like a pretty big jump from part B, I'd say. But I say this problem itself is pretty straightforward. So let's look at it. The values 2, 3, 4, and 5 are each assigned to exactly one of the letters V, W, X, and Y to give this expression the greatest possible value. So what's the value of X plus V? And you could basically guess and check this solution. Even though there are like 24 combinations, you could still, I don't know, it's pretty easy to guess and check. So let me know when you guys have an answer. Elaine says D. I think D is correct. Mhm. Okay, let's give you guys a couple more time just to figure out yourselves. Think about why it's 8. Okay, let's take it up. It's a fairly straightforward part C problem. But, so this was the expression that we're given. What is it? So yw, sorry, yx, so y to exponent x minus wv, I believe. Yeah, wv. wv. This was the expression that we're given. And the question wants us to like maximize it. So we want the largest value of this. And usually the way you do that is you want to give this value, so y to exponent x, you want to give this the largest value possible. And then wv, w to exponent v, you want to give this the smallest value possible. So if you have a really large value minus a really small value, you would get your maximum value. Hopefully you guys can understand why that is. But it's fairly easy to understand if you try it out. Well, yeah, so we want to find the largest value of y to exponent x, and then we want the smallest value of w to exponent v. And so we have the numbers 2, 3, 4, and 5. And we want to substitute those into these variables. So it'll be pretty obvious that we want to give 4 and 5 to, to y and x. And then we want to give 2 and 3. We want to put 2 and 3 with w and v. We want to give the smallest numbers to wv. And then we want to give the largest numbers to yx, right? Hopefully that makes sense to you guys. So if you try out all these values, so we have for yx, you get y equals to 4, and then like x is equal to 5. You can also have y is equal to 4. Sorry, y is equal to 5, and then x is equal to 4. If you try to find each of those values, you want to find which one's the bigger one, right? And then for same thing for the wv, except you want to use the smaller value. So you could do w is equal to 2, v is equal to 3, or w is equal to 3, and v is equal to 2. So we try to calculate these. So 2 exponent 3, that would give you 8. 3 squared would give you 9. So we want this value as wv. And then for 4 to exponent 5, I believe that is 1024. Okay, yeah, 1024. And 5 to exponent 4, that should be 625. Let's see. Yeah, 625. So that means you want to use this value for exponent 5 as your largest value. And then you want to use 2 exponent 3 as your smallest value, which is wv. Right. Let's scroll down a little bit. And you can probably see why this is the maximum. You can see that if you subtract these two, that's the maximum value. And so the question wants us to find x plus b. So this is our final answer. So we have x would be equal to 5. V, so v is the exponent right here. So basically the two exponents. That's what we want to find. The sum of the two exponents, 5 and 3. And if you add those up, you get 8 as your final answer. So if you go back to the slideshow, you circle answer D right here. Okay, any questions about this? Okay, if there are no questions, let's move on. Next one, problem 23. This is actually a much bigger jump from 22. Okay, so let's look at it. Mike and Elaine are play a game in which each player is equally likely to win. So it means that both of them have like 1/2 of probability to win a game. So the first player to win 3 games becomes the champion, and no further games are played. If Mike has won the first game, what's the probability that Mike becomes the champion? Okay. So I don't expect you guys to like actually come up with an answer like really quickly, but just think about like the process you'd use to actually solve for this. Okay, I'll give you guys a minute to digest it. Aiden, yeah, I think that's the right answer. How did you get it so quickly? It's it does seem overcomplicated, but yeah, you can simplify it pretty easily. Did you guess it, or you just that was a guess? Okay, just because you saw it, like because it had 2 digits or something. No, I don't know. Nice guess though. We'll see why it's that. Hopefully, you guys had time to try to think about a solution. Don't try to solve for it, but just think about how you'd approach this problem. Yeah. Okay. Let's take this up. So what we actually want to do is we want to figure out like all of the possible like sequences of games in which Mike actually wins, right? So so a question asks for like if one player wins 3 times, that means they become the champion. So we want to figure out all the possible sequences where Mike wins 3 times. So basically what we can do is just like, I don't know, just given like number of games we have, we can like fill these in with either Mike or Elaine. So M or A as a champion. And I want to figure out like all of the possible like combinations of those, right? But that seems like a pretty tedious task. So we're gonna try to like an example would be like this. So Mike has to yeah, Mike. He has to win the first game. That's guaranteed. And then we're just worried about like the rest of the sequence, right? So say like Elaine wins the next 2 games after that, but then Mike wins the next 2 games after Elaine wins those games. And so in this case, Mike would become the champion. So this is one example of like a sequence where Mike wins. Sequence of games. And we want to find all of them, but how do we do that? Well, what we want to do is we want to draw out a tree of all possible outcomes. So what a tree looks like, it would just be we branch out, and then we basically like try to we basically try to write down all the possible outcomes. So say this was like round 1, and then you have round 2, and then the next branch. So pretend each of these are branches. Then you try to draw out what round 3 looks like, or round 4, and etc. And let me get some more space first. Let me try these. Let me make this tree a little bit smaller. So round 1, Mike has to win the first round. Round 2, you can see that either Elaine or Mike could win. So this is round 2. Round 3. Now from each of these branches from round 2, you draw even more branches. So you also have Elaine right here. So for each of these branches, you just draw another branch for Elaine and another branch for Mike. That's how you do it. And that's how we can find all the possibilities. We just like circle like which ones have 3 M's and not 3 A's. And for some of these, you can see that like for this possible path right here, M, you see that already counts as a win for Mike. So we're not going to extend this anymore. I'm going to extend it from this branch. So the branches where no one has one, we continue to expand them, like extend them, until we get a person that actually wins. So for this one, you get Elaine and Mike. Same for this one. This one as well. You can branch out to Elaine and Mike. And you just keep doing that. It is a bit of a tedious process, but this is basically the most efficient way you can try to come up with all of those outcomes. And the fifth round. So you see that Elaine has won. So for this branch, you see Elaine won 3 times already. So we're not going to extend this anymore. We're going to extend this M right here and draw another Elaine and Mike. All right. And then we just keep doing that. It's fairly tedious. So you see for this M, you can see that Mike has won 3 times over here. So we're not going to extend this one anymore. Just going to draw our A and M over here. For this one, so let's look at these two. See that we follow down this path right here. No one has won yet. So it means we have A and M. For this path, you can see that Mike has already won, so we're not going to draw that anymore. And then after that, and 6th round, maybe we don't need a 6th round. Let's see. So say we took this path. Elaine has already won. See that A. So we don't need to extend that anymore. And we see that for Mike, we also have 3. M. Same for this one. We have A. We don't need to extend that anymore. And then for this M, we also have M. So we do not need a 6th round. So it takes a maximum of 5 rounds. Sorry, yeah, it takes a maximum of 5 rounds for before someone actually becomes a champion. Yeah. So you can see it was kind of tedious, but that's the end of the tree. And then from here you can just, and from here you can figure out all of the possible like rounds, like all the possible sequences where Mike actually wins. So you try to follow like any branch or something. Try to figure out which one has 3 M's, right? So most obvious one would be this one right here, where all 3 of them are M's. I bet 3 M's right here. You also have MAMN right here. Another one. One. You have MMAM. So let me draw it out. Let's use a different ink. See if I can change that. Yeah, this becomes different ink. So MMAM, that's also a possibility. Oh, did I not draw it out? MAM. And there are a couple more, I believe. Yeah, there's a lot more. So we have MAAMM. That's also one. We also have MAMM. No, we drew it already. So we have MAMAM. That's also one. It's getting really messy. I'll list them all out. MAAM. Okay, I think there are only these 5, but let me guys know if you find another one. So we're just gonna stick with these 5 for now. Actually, wait. MAAMM. Yeah, found one. Okay, found another one. MAAMM. That's another one as well. And so we want to find the probabilities that each of these rounds actually happen. So that's how we calculate the final probability. And basically we can just add them up. And remember that the first round has to have Mike winning. So we don't count like the probability for the first round where Mike wins. That's just going to be 1. Okay. So say if we had 3 rounds. So we had 3 rounds. So the probability of the first round is just 1 because Mike has to win that. And then for each of the next few rounds, you have 1/2 of a probability for like Mike or Elaine to win. And same thing for the 4th rounds and the 5th rounds. 1/2 and 1/2. So say if you had 3 rounds only, you would have a probability of 1/2 times 1/2, which is a quarter. We multiply all of these if you want to get your probabilities. So if you have 3 rounds, you get just 1/2 squared. If you have 3 rounds, sorry, 4 rounds, so say the first round all the way to the 4th round, you get 1/2 cubed. And say you have 5 rounds, you'd multiply 1/2 by itself 4 times. And so we can do that for all 6 of these possibilities. So we only have one possible way. We only have one possible 3-round game. So MMM. So that's a quarter. Now we have 2 games with 4 rounds. So MAMM and MMAM. So that means you'd have 1/2 cubed. So 1 times 1/2 times 1/2 times 1/2. That'll give you an eighth. And there's 2 of them. So let's just multiply that by 2. And then the remaining ones have 5 rounds. So MAAMM, MAMAM, and MMAAM. Those are 5 rounds each. And so for 5 rounds, you get 1/16. So we multiply 1/2 by itself 4 times. And this is just multiplied by 4. Sorry, 3, because there's 3 of them. There's 3 of these. So 1, 2, 3. If you solve for this, so I have 1/4 quarter plus 3/16. Right? And then if you finally add these up, you'd get 11/16. And that's your final probability. All right. And this is your final answer for the problem. So it was fairly tedious trying to get all those combinations, but that's basically how you try to solve this problem, right? Any questions about this? So you'd circle C for this problem.